So we would like to find the intervals of concavity of the function e to the negative x squared, which means that we need to study the sign of the second derivative. So let's find the second derivative and simplify it as much as possible. So f prime of x, according to the chain rule, is going to be e to the negative x squared times negative 2x. And now, since this is the product of two functions, we need to apply the product rule. And this is going to be the derivative of the first, which is, we already found it, times the second, so we get two of these, negative 2x's, plus the first function times the derivative of the second, which is negative 2. So what we have here is we factor out e to the negative x squared, which is a quantity which is always positive, and we have 4x squared minus 2. And so this will mean that the second derivative is equal to 0 if and only if 4x squared is equal to 2, which means that, so this is because this quantity is always positive, and this is if and only if x squared is equal to 1/2. We divide both sides by 4, which gives us that x is plus or minus 1 over square root of 2. So these are the two numbers that we have to place on our monotonicity diagram, on our concavity diagram, I'm sorry. Negative 1 over square root of 2 and 1 over square root of 2. So we will have f double prime and f. So we know that it's 0 right here. Now, again, since this quantity is always positive, we just need to look at this quantity, which for x really large is positive. It has two roots and it's a polynomial of the second degree, and this means that it changes sign across every root. So we will have minus and plus. And this means that the function is going to be concave up, concave down, concave up, and this is going to be an inflection point. And this is another inflection point. So we have that f is concave up on the interval from negative infinity to negative 1 over square root of 2. F is concave down on the interval from negative 1 over square root of 2 to 1 over square root of 2. And f is concave up on the interval from 1 over square root of 2 to positive infinity. And this completes our study of concavity for this function. Thanks for watching.